A common type of homework question could be asking you to determine, is a sequence arithmetic, or is it geometric, or is it neither? And basically, in order to do that, you would just want to figure out, is there a common difference, or is there a common ratio? And if there's not a pattern that's identifiable based on arithmetic, adding, subtracting, multiplying, or dividing, then you know it is neither. So looking at the first one, we have 2, 4, 6, 8. Who do we appreciate? Math. Sorry, another bad joke. But we can see that it is growing by 2 each time. So since the common difference is 2, this sequence would be arithmetic. And you know, once I identify it to be arithmetic, which is the same word as arithmetic, but for some reason pronounced differently, there we have it. And again, if I wanted to write the formula, I could begin with the formula for the formula. It's always the first term plus n minus 1 times the common difference, d, 2. And I could simplify. Or actually, that would just simplify to be 2n, because each term is just twice the index. The second, if we're looking at the second one, very similar, has the first 2 terms, but instead of growing by plus 2 each time, we can see that it's doubling, multiplying by 2. That is always a geometric sequence when it is being multiplied by the same thing from term to term. Whoops, I spelled that incorrectly. Geometric. No, I didn't. Thought I did for a second. Anyways, and so yeah, the formula again would be instead of given by, instead of being 2 plus n minus 1 times d, it's going to be a times r to the n minus 1. So instead of having n minus 1 multiplied by its difference, it's going to be the base raised to the n minus 1 power. So it'd be 2 multiplied by 2 to the n minus 1 power. Or actually, in that case, we could even simplify that because technically this is a common, like we could write notice that both of those are 2, and we could look at the first one as 2 to the 1 power. So we could actually rewrite that because since it's the same base, we can add the exponents together. This would be 1 plus n minus 1, which would just be 2 to the n. And notice that this formula right here is just a pattern behind 2 to the x power, and an exponential function base 2, where it's just doubling, 2 to the n. Whereas this one was just 2 times n. Key difference between them. Now looking at some other ones, if I look at the third sequence on this example, I could look between them 2 to 5 to 10, like it's growing by 3, then 5, then 7. And the thing we might not know is, well, it's clearly not being added by the same thing, but is there a common multiplier? And what you could do if you're not sure if it's geometric or not, is you could actually check between the terms. Well, like between 5 and 2, that would be multiplied by 2.5. Between 10 and 5, obviously that is multiplied by 2. And from 17 to 10, that's not a common ratio either. There's no common ratio, there's no common difference, and you can check that by subtracting the terms or by dividing the terms. So basically, this would be an example of neither arithmetic or geometric. That doesn't mean that it doesn't have a pattern and that we can't figure it out. And actually, this sequence is the sequence n squared plus 1. Which, notice that it's neither an exponential or linear function. It's something differently entirely. It's actually represented by a parabola or a quadratic function, but there's no special name for this, at least in our book. And it's not, really arithmetic and geometric sequences are some of the more fundamental types of sequences when it comes to calculus and other math. I mean, other sequences are also important, but they just don't have a special name. And there's no basic formula or pattern for discovering what they are. You just would have to sort of recognize, how do I recognize this pattern? In terms of actually figuring it out. And looking at a few more, the next one appears to be subtracted by 11 each time. So this one should be arithmetic. I'll leave it as an exercise for you to figure out its formula. The next one, also, notice how when it's if a sequence is ever what's called alternating, switching between positive and negative, it could never be arithmetic, because if you're adding or subtracting the same thing every time, it can't change. It should either be getting bigger, bigger, bigger each time, or smaller, smaller, smaller. It should never be switching back and forth between positive and negative. But actually, geometric sequences can be alternating. because when you're multiplying from term to term, if you multiply by a negative each time, it will swap from positive to negative. And also notice about this one is the absolute value of each term is being cut in half. And remember, when you're dividing term by term by term, that's always geometric. So here, this one would be geometric because each term is being multiplied by 1/2, and each term is being multiplied by a negative. And if we wanted to write its formula, I'll leave it as an exercise for you to do, but just remember that the common ratio here would actually be -1/2 because it is being cut in half, but it's also being multiplied by a negative each time. And the next one, I'll leave the last two for you to figure out with decimals, but it could involve decimals or any sorts of numbers, which could make it a little bit more challenging. But I believe these are both either arithmetic or geometric, if I can remember off the top of my head. So in the next video, I want to talk a lot about series, which very, very similarly, but the next thing we can kind of consider is what happens if in a sequence we were to add up the terms and examine the pattern behind that sum. That's the idea of a series, and a very crucial idea in a lot of higher level math.